Hi, I'm Brad Peebler, and this is LightWave 3D Render One. The LightWave 3D render engine is world-renowned for being one of the most powerful and flexible rendering engines on the planet. Now, it's important that you understand some key concepts and technologies so that you can control that render engine to do whatever you want for your current project. Whether it's cartoon style, all the way up to photorealistic, LightWave can handle it, but it's important that you understand the basics of that render engine to really manipulate it. All right, let's go ahead and take a look. The first key setting for the LightWave render engine is the resolution. What's your target output? Let's go to our camera option here. You choose the camera at the bottom and then click on Item Properties or hit the P key. And that'll open up your camera properties. And you can see here we have resolution, and there are several standard resolutions available. You can also just type in a resolution directly here. All right, we'll start off with a straight VGA res here, and I'll hit F9 to render. That renders my frame. And then you can see that our full screen display opens up. Now this is a 640 by 480 resolution image. Okay? If we change this to say 64 by 64, just by typing in to our width and height settings there, we can re-render, and you see now we get a tiny little image here. This is one of the great things about working in 3D, is that LightWave is always going to generate a bitmap to output. However, the graphics that you're working with, the LightWave scene description, the objects, the model files, the lights, things like that, they don't have any real resolution in them. So really it's just the camera setting that determines what that final bitmap's output resolution will be. That way you can take a scene and render one frame at low res for an icon for a web page. You can turn the resolution up, render it for D1 video output. Then you can turn the resolution up again and render it for a high res print frame as well, all from that same scene description. That's one of the most powerful things about working in the 3D environment. All right, let's go ahead and take a look at a more basic approach to what resolution is and how a bitmap is created. So we're going to load up a frame here. And this is just a regular D1, which is industry standard for video. This is 720 pixels by 480 pixels, or 486 pixels actually. But what's a pixel exactly? This just looks like a regular image here. If we zoom in, you can see the closer we get, you start to see little blocks. Okay? And those little blocks are what make up the picture. And you can see here, as we get really close, we have tiny little squares, and these squares are each pixels. All right? So if we take several thousands of those pixels and you put them all together, that's what creates your image. All right? Now, the advantage to that is you can store these things very compressed. However, the disadvantage is that if you want to scale this up, just like we're doing here, we want to zoom in, there's only a certain limit you can go before you really start to break up the image there. So it's important that when you first do your render, you know what your target output's going to be for, and you choose that render resolution. For example, if I rendered at D1, 720 by 486, and later I needed to crank that up to print res, you wouldn't want to just scale that image, because just like when we zoomed in here, that'll start to break up. Fortunately, if you did that scene originally in LightWave, you can just change your camera settings, and you should be fine to render at a print res. Okay, let's go back to our little resolution logo here. And we're going to talk a little bit about the resolution settings. So once again, we go to Camera, hit the P key to bring up our properties, or click on the Item Properties button here. Again, you'll choose your resolution. Now you see LightWave comes complete with many defaults here. VGA, these different VGA and XVGA settings are for standard computer resolutions. You've got D1 and D2. These are for NTSC, which is video output. You've also got widescreen and PAL output, as well as some HDTV settings. Now let's just say we want to do a D1 resolution frame. We can choose that, and you see that it sets my width and height to 720 by 486. Okay, that's the appropriate resolution. Now there are many times when you're doing renders, you might have a very complex scene, and in that scene it might take several minutes to render one frame. Well, if you're doing tests, you don't want to always spend several minutes to render a frame. So what you can do is you can scale that resolution by the resolution multiplier. Okay, so what we see here, right underneath the resolution identifier is the resolution multiplier. And here we can choose 50%, and that'll automatically multiply that resolution so that I know when I make my test frame, I'm getting basically 1/2 the resolution of my regular NTSC. That way it will also render in about half the time. So you can see there, of course these are rendering very quickly because it's a simple scene, but it's a very quick way to reduce your render times while you're doing tests. Now, another setting that's important to understand is the pixel aspect ratio. All right, for video it's set to 0.9. That seems a little strange. If we look at VGA here, you'll see it goes to 1.0. On a computer screen, your pixels are always square. Okay? On a video monitor, pixels are actually rectangular. They're taller than they are wide. So your pixel aspect ratio has to change. If LightWave didn't have an option to set that, it would render everything in square pixels, and then what you saw on your computer monitor would look different than what you saw on your TV monitor because everything would be squished upwards a little bit. Okay? Be about 90% as wide as it looked on your computer monitor. So LightWave automatically adjusts for that. When you set it to a video resolution, it knows that D1 has a 0.9 aspect ratio. So the nice thing is, depending on what output medium you're going to, if it's embodied in this list here, you'll see LightWave will automatically update that. So if we go to D2 NTSC, LightWave automatically adjusts the pixel aspect ratio. But it's important that you understand what that means. So in case you're going to a variable format, if someone tells you they need a different pixel aspect, you'll know why you need to set that to keep your image from being distorted. There are a lot of people coming from the print industry who are now getting into 3D graphics. There are also a lot of 3D graphic artists now who are needing to do work for print graphics. And 3D artists and video artists always think in terms of resolution, which is number of pixels. Print artists always think in dots per inch. So how do we cross that barrier? In LightWave, we're always talking about pixels. So let's take a look at how we would deal with DPI, or dots per inch. So I'm going to load some images here to give you an example of our billboard. So the client comes in and they tell you they want to build a billboard and they want you to render a logo for it. Okay, and you think that's pretty cool. They've normally been doing video graphics. You're excited about doing a billboard. But they ask you to do 72 DPI, but the billboard is going to be 20 feet across by 8 feet tall. All right, well, what you're going to want to know is, what's the resolution I'm setting? All right, is it 8K by 8K? Is it a 2K image? What is it? All you know generally is that LightWave gives you these options for the standard resolutions. You've never had to go out and set your own custom resolution. Well, let's take a look at how we calculate that. As we know, it's going to be 20 feet across. So to get this resolution for the horizontal resolution, we can say 20 feet times 12 inches. That gives us the number of inches across the billboard, times 72 dots per inch equals 16,000 pixels. So you're going to have to actually set this up to 16,000 to render a 20-foot wide banner. Now to go the height here, we have to go down to 8 feet times the 12 inches times the 72 dots per inch, and that gives you a resolution of 6,912 pixels. And of course, that's going to be a resolution of 16,000 by 6,912 pixels. Once you've got that, you can go into the LightWave Render Engine, type it in, and LightWave will render your appropriate banner graphic at that resolution. As far as you're concerned, your camera settings are in here, 16,000 by 6,912. But the print house, when they get it, all they see is a 20-foot by 8-foot graphic at 72 DPI. Now, you may wonder about doing that calculation. I obviously didn't do that in my head. I also didn't use a calculator. One of the great things about LightWave is all these numeric fields allow you to type in numeric functions directly. So I can tell it 20 feet times 12 inches times 72 dots per inch, and it tells me the right amount immediately. I can say then 8 feet times 12 inches times 72 dots per inch, and again, we're good. So that way, if a client comes in, they want a different DPI, again, you just type in feet times inches times the DPI resolution that they want, and then LightWave will automatically calculate what your target pixel ratio should be. All right. Okay, the next thing I want to take a look at is the segment memory limit. And to do that, we need to have a scene that has the entire frame covered up so I can show you what's happening. So I'm going to load a scene here. This is just a little scene I whipped together. It's just got some little primitives laid out on a ground plane. And we're going to go back to our camera properties. And you can see under segment memory limit, there's a listing for segments. Right now, it's going to render the whole frame in one segment. If I open up the segment memory limit, you can see the option here is set for 16 megabytes. That means it's going to use 16 megabytes of RAM to hold this frame while it's rendering. All right? If I set that down to 8 megabytes of memory, we say OK. It's going to come up and ask me if this should become the new default. I'm just going to say no, because for this time I'm just going to set it up as an example. The reason you might say yes is if you find that your computer has a low amount of memory and you're constantly paging onto virtual memory. You can set that setting to a lower setting so it renders the frame in chunks, which is I'm going to show you here in a moment. But you may want that to happen all the time, not just on one particular scene. So you tell it to go ahead and be the default, and then anytime you launch LightWave, that segment memory of 8 will be the default. In this case, I don't want to change that default. I just want to show you. So I said no, and great. Now you can see my segments are set to 2 here. All right. So if I hit F9 on my keyboard, that's going to render the current frame. And you can see it renders the top half of the frame first. Okay, there it goes. And now it's going to render the second segment on the bottom there. Hence the 2 segment setting. Okay, so the advantage here is that it's going to use less memory during the render of each of these segments. The disadvantage is it's going to take a little bit of extra time to render than it would if it did both segments at the same time. Depending on the frame, it can be a couple seconds per frame added on there. Now, there are a couple other disadvantages to segment memory limit setting that lower to render in more segments. If I set this down to, say, let's go with maybe 1 megabyte, and again, we don't want this to be the default, so I'll say no. Now you can see this is going to render in 12 segments. Okay. Now, while this frame is rendering, what you can see is it's rendering the tiny little segments here, but it's also doing some smoothing on these shadows, which is sort of a blurring effect on that shadow. So what's going to happen is, when you render in segments, if there's any kind of process that has to happen on each pixel, when it renders one segment, when it processes a pixel on that edge, it's going to kind of blur in between that black in the back here because there's nothing underneath it yet. So you need to render the full frame in one segment for some of those post-processes. Now, LightWave tries to be smart as much as possible and keep that frame in memory for things like image post-processes. But just be warned, if you see a frame that gets rendered with multiple segments and you see some strange discontinuities, then you'll know that you're getting an error because of that segment render. And we can go ahead and take a look here at our frame. And you can see, if you look closely, if we'll zoom in here to this picture, you can look and you'll see little discontinuities here, here, here. That's where the edges of those segments were. Okay, you can actually see them, and that's because I was doing a post-process blur at each segment on the shading of the graphic. So what you want to do is make sure, if you see that, you're just going to have to go ahead and crank that setting back up so that it renders all in one segment. Now, another thing to keep in mind is this segment number here is also dependent on the resolution. So if we go back to our segment memory here, we set this back to 16 megabytes, you can see that my segments are back to 1. All right? But now if I double my resolution, okay, you see now I've actually got my segments up to 4. All right? Because it's going to take more memory to render that. Now, you may wonder why I doubled the resolution and now it's going to be 4 times the memory to render that. Well, keep in mind, when you double the resolution, you're actually quadrupling the number of pixels. So if you had a 640 by 480 image here, a 1280 by 960 is 640 by 640 together, make the 1280, and then 2 more segments here for the doubling of the 480. So anytime you double resolution, you actually quadruple the number of pixels, and thusly you quadruple the amount of memory required. Okay, that pretty much wraps it up for segment memory limit. Just keep in mind, you generally want to keep your segments at 1, if at all possible. It's going to be faster, and you're going to avoid any potential render errors. If you see your computer start to page, or if you're running low on system memory, that's when you'd go ahead and lower that segment memory limit to save yourself some RAM. Again, at the expense of potential render errors, depending on post-processes, as well as a little extra render time. Those options are set here on the Render Options panel. First of all, there's the Show Rendering in Progress. That's what gives you a little proxy window that shows a small version of the render while it's rendering. And secondarily, you've got the Render Display set to Image Viewer. There are actually 3 settings here. One is None, one is Image Viewer, and one is Image Viewer FP. We'll explain the FP in a little bit here. These are actually plugins, so you can actually check out other third-party displayers on flay.com or from different places on the internet. And if you add new image displayers, they'll just pop up in this list here. All right, we're going to leave this on Image Viewer, and I'm going to talk briefly about Show Rendering in Progress. If I turn this off, it'll actually just give me a tiny little render display here that shows the parameters while it's rendering, and then it'll show the display here. Now, the reason you might want to turn that off is that when you have the Show Rendering in Progress on, it actually takes a little longer to render. And if I click on it, it'll tell you, using this option may result in longer render times. Okay, that's just because the computer, it takes a little bit of time for the graphics card to take the pixels out of memory and blit them onto screen. All right. Now, it may only add a second or 2 or 3, depending on your graphics card. But if you're rendering a 1,000 frame animation, that can actually add up. So while you're doing render tests, I usually leave it on for my F9 so I can see the low res. I don't care about those 2 or 3 extra seconds. It's worth it to be able to watch the rendering happen to make sure there are no errors. However, when you finally go to do your final render output, I do recommend turning that off for rendering multiple frames. Okay. And to go ahead and finish up with the image viewer options here. First of all, the image viewer FP will save what we call the floating point data in the LightWave renderer. When LightWave renders, it saves out all kinds of extra buffers. And if we have the image viewer FP turned on, it's going to save all that data in the screen. Okay. Now, it doesn't look any different, but what has actually happened is if there's any high dynamic range data, which we'll cover later, if there's any other buffers, it's going to maintain all that. So you can do some interesting image post-processing right here from the image viewer. All right. Now, other things we can do with the image viewer, and this works with either the image viewer FP or the regular image viewer. So we can go here, and you'll see there are a couple options. First of all, you've got layer and image. The layer is set up to display multiple frames that have been rendered. So if I go here and I drag my slider a little bit forward, and we render another frame here, you can see there's the frame I've just rendered, but under layer, I can go back and look at the previous frame. So if you're doing render tasks, it's a good way if you're changing surfaces or you're just checking the animation, you want to see 2 frames back to back. Let's say we want to render the next frame here. We go ahead and step forward to frame 29. Hit F9. Okay. Now I can actually switch back and forth between the 2 frames, and I can see that little bit of animation in between those 2. A good keyboard equivalent here is page up and page down on your keyboard. So I can actually just very quickly, I'm just toggling page up, page down on my keyboard here, and you can see that that switches back and forth so I can get an idea of the, it's kind of like artists or animators that use a flip book to page through there. You can also change from image to alpha. And alpha will show you the alpha channel that's been embedded in that image data. Okay, so you can see that if you want to take a look at the alpha channel data, if you're going to be doing any compositing, that's very important. Finally, over here on the file pop-up, you'll see we have save RGB. And this is how you can just go ahead and save out a single frame that you've rendered. So if you're just going to be doing test renders and you see one that you like, maybe you want to send a test frame to the client, you can just come in here and choose any of LightWave's different image savers, from alias all the way down to YUV and everything in between. Obviously, there are many different image formats, and different formats are relevant to different uses. For example, if you're using something for a high-end compositor, you might want to save out as Cineon. If you're just sending it out for the internet or as a test frame, you can compress it with JPEG, so on and so forth. Other options you have here, you can actually clear a layer. So this is very important, especially when using the Image Viewer FP, because Image Viewer FP, while it saves all that extra data in the frame, all that extra data comes at the cost of memory. So what you can do, if you want to keep these 2 frames, but you want to go ahead and clear this one out to clear memory, I can go down here and say clear current layer. Now, what I can also do is go over to the layer here, and you can see that I've got the name of the scene, scoutwalk.lws, followed by underscore and the frame that was rendered, followed by the number of frames that had been buffered in the image viewer. So what I can do now, let's say I want to look at frame 28 versus frame 30, okay, instead of frame 29. So I come down here, and I go ahead and move my frame slider to 30. Again, F9 to render that current frame. Okay. Now again, I can come up to my layer pop-up, and I can choose frame 28, and then scroll down to frame 30. But if I wanted to use that page up, page down trick where I can actually scroll through like this, but I don't want to see 29 in between them, so again, you go over to File, Clear Current Layer, and that kills a frame in between. And now I can use page up to page down, and I can see now 28 versus frame 30. And again, you'll notice even right here in this little window, you can see the current frame number. So I can see exactly that I'm looking at frame 30, 28 versus frame 30. Okay? This frame up here also displays the resolution that was rendered at and the bit depth. And you can see here this is showing 128 bits of information. Now when I was talking about that image viewer FP saving those extra buffers, the 128 bits tells you exactly how many different buffers have been saved. What that stands for is 24 bits of color data. Okay? Then you've got another 8 bits for alpha channel, which gives you the 32 bits. Then there are other buffers like depth buffer, which is called a Z buffer. There is a motion buffer stored in there. So all these different things will add up to a total of 128 bits. So you can know exactly how much data is being saved. Again, what you want to do is you start to stack up lots and lots of frames in there, is clear out some of those. Or if you want to clear all of them, you just close the window, and then the next time I do a render, it'll come open, and this time you'll see in my layer pop-up, there's only that one current frame. Okay, so that's how we would save a single frame. That's how we view frames, but this is mostly for preview, and that's also how we can save a current frame. Other things we can do here are some image controls. All right, and because this is the image viewer FP, what I can do is I can actually tell it to turn on exposure. All right, and then I can change the white point. All right, so if I decrease the white point, it's actually going to boost the whites. This is sort of an advanced gamma correction. You can also set the black point, which is going to change where things get shadowed. So you can really change the look of the frame to make it much more dramatic. This really comes into play when you have really bright lights. The thing about LightWave when it does a rendering is that it saves all of its lighting information and shading information in a linear format. Okay? Most 2D graphic images, even most 3D renderers, will save it with a curve, what we call a gamma curve. All right? Well, that's not natural to the way our eye actually sees light. When you see light in the real world, that light intensity changes in a linear fashion, and that's the way LightWave stores that. However, because the computer screen can't display that accurately, you do have to apply some sort of filter onto it, which is generally a standard gamma correction. In the real world, when we process film, you do the same thing. That's what we call exposing the film. All right? And then we take that and process it, and you can change the contrasts of those photographs. Same thing applies here. We go in, and now you can adjust the exposure settings right here in LightWave. And again, you can actually just drag these sliders if you want and see that happen, update in real time as I'm dragging it. So as I increase the white point, it gets darker. Decrease the white point, and it's going to blow out those white sections. So you can see how it really gets hot there by decreasing that white point. The exposure setting on the image viewer FP, like I said, is a lot like working with film. However, it's only working on that one single frame. Keep in mind that when you're working in the image viewer, that's just treating what you're working on. So if you do a save or if you do an image expose, anything you do is just happening right there on that one frame. Now, why would you want to expose just the one frame? If you like that, you might want to apply that to your entire animation. You certainly don't want to come into image viewer for every single frame. So there's actually an image filter called HDR expose. Let me show you that real quick. Okay, so let's just say this is a little too bright. So let's bring our white point back up to 0.5 and leave our black point at 150. Okay, so we know that that looks good. But again, if I close that, that's only going to happen on this one frame. Now, if I do want to save that one frame right now, I can go ahead and do a save exposed. All right, and it'll save out the exposed version of the frame, so I can keep that. However, as I mentioned, I want to do this to the entire animation. So we go over to our Scene tab here, go to Image Processing, and under Add Image Filter, you'll see one called HDR Exposure. All right, and again, we open that up, and you can see here, now we have the same settings. So I would just type in 0.5 and 150, just like I did there, and now when I do my render, you'll see it does the render, then it adds the exposure, and again, without me having to make any settings, I get my modified frame. Okay, there's one more thing I want to talk about under image controls, and that is the blend mode. Now right now we have 2 frames, and we can see that changing by clicking here. You can see the image down here changing between frame 30 and frame 21. If we want to compare those 2 images back to back, these 2 are a little strange because they're completely different frames for the blend mode. But what I can do is put one image in the background. You'll see here I have foreground, and that's checked. Background, I check that. And now I've got an option for blend mode. And right now it's set to dissolve. So if I go to 50, it's going to do a 50-50 dissolve between frame 30 and frame 21. And I slide that over, and you see it blends more over to one side or more over to the other. You can also do things like a horizontal or vertical blend. So here you can see it's split. This is really more applicable when you're doing surface changes or image process changes to a single frame. Then you can put 2 different rendered versions of the same frame. Say you're adding a post-process blur and you want to get the setting just right. Well, you can render it twice with 2 different blur settings, and then in the image controls you can go in here and do either a blend or horizontal wipe, a vertical wipe. You can do all kinds of interesting things with the blend mode, so you can compare those images together. Okay, that pretty much wraps it up for those. Let's go ahead and talk a little bit more about render output settings. So we're going to go back over to our render options panel. And again, that shows how your frames are going to be displayed. Once more, when you're finally doing your final rendered output, you want to turn this off, and you want to turn off Show Rendering in Progress. It's going to save you a lot of render time hassles when you're starting to do your final actual animation render. Okay, again, I turn these back on, and it's warning me that it takes longer to render, but we've already gone over that, and that's okay. And we'll bring up our image viewer. Fine. Okay, the next thing I want to talk about is output files. Right now it defaults to the rendering tab being open, and we'll talk more about these ray trace options when we discuss the lights. For now, let's talk about our output. And what we need to know is, are we going to save an animation? Are we saving RGB files, single image frames? Do we need to save the alpha as a separate frame, or is it embedded? So once we've decided that, we choose the appropriate thing. Now, one of the nice things about LightWave is we can save all these things at the same time if we want to. The difference between, say, saving animation versus saving a RGB, you might think, well, I'm rendering an animation, so you always want to do save animation. What that means is animation file. So that's like an AVI or a QuickTime movie. Okay? Whereas save RGB, it'll still save out every frame of your animation, but it'll save them out as separate image files. So you'd be creating an image sequence as opposed to a movie file. All right? So once you know which one you want, you go ahead and turn that on. So we say save animation, and then you just need to tell it the name. We'll call this bot walk. Okay, and we'll say .avi. So we're going to save it as an AVI. And what we need to do now is choose the type. And you can see in here there are many different animation types. From storyboard, this will actually save out images that have multiple frames on each image. It'll create little storyboards for you automatically. AVI file, which is what we're going to use. Film expand, if you want to do a 3:2 pull down, this will do it for you automatically, which is pretty cool. That's a little bit more advanced. If you're not familiar with 3:2 pull down, that's a film to video conversion utility. QuickTime movie, it'll do a QuickTime VR movie, a QuickTime stereo movie, which will do the red-green separation for you, and again, another storyboard that just puts more frames per frame. But again, we want AVI. The 2 most standard are going to be AVI and QuickTime. These are pretty much the only ones I ever use. The other ones are pretty specialty. We choose that, and now you have to choose the options for your AVI movie. And this is the same thing. If you use QuickTime, you're going to have to do the same. Choose your codec. Codec stands for compressor, decompressor. So this is going to be the method that you use for compression. And each user will probably have different codecs on their machine. Just depends on what's been installed in your Windows installer. All right. I'm not going to go through each one of these. They all have their own attributes. But you can choose whichever one you want. If you're not sure, or if you're going to be using this movie over again, choose full frame uncompressed. That'll just save each frame in that movie file uncompressed. It won't distort it at all. You say OK, and then you need to do the render. So to do the render, instead of doing an F9, we'll go back up here to rendering. Again, F9 was set for render current frame. Render scene is F10. And this will go through and actually render all of the frames in your scene. All right, now there's a little gotcha here that I want to cover really quickly. Where does it get the number of frames? Well, you have to look at your render options here, and you can see that it says render first frame is 1, render last frame is 54. If we zoom back out here, you can see on the bottom of the screen our time settings. I'm going to go ahead and close these windows. Our time settings are also set. Frame 0 here is the beginning, and over on the other side, frame 54 is the end. Okay, so it happens that those match up. And these settings here, the 0 to 54, tells me which frames I can preview by dragging my slider. So if you just want to look at these frames here, you can say, okay, I only want to look at frame 10. Just type that in at the bottom on the left, to frame 25 on the right. And now you can see it's only previewing that one little step. So if I push play here, my OpenGL is just previewing that one little chunk. All right. Now, when I go to render, if I go back to render options, this is still set to frame 1 to frame 54. Okay, this is a real gotcha. In this case, it wouldn't be too much of a problem because you're doing a limited section. But let's say you're working on your animation. We'll get this back to 1 to frame 54, and you decide it needs to be longer. So you go ahead and type in 150 down here. Now you've got all these extra frames in your animation, right? And you go to render it, you come back the next day, and you find out it only rendered the first 54 frames. Again, that's because the settings on the main screen here that we just set up 1 to 150, that's just telling you what you can interactively preview through. Okay, that has nothing to do with what's actually going to be rendered. So you have to make sure before you do your final render to go into Render Options panel and set up the appropriate first and last frame. This actually got me a couple times when I first started using the new system, where I'd stretched out my preview frames here to 200 frames, and the default in LightWave is to render frame 1 through 60. You go home, you think you're rendering the whole animation overnight, and you come back, and you've only got 60 frames. So buyer beware, make sure you set that first frame and last frame on the Render Options panel. Okay, so let's go back up into our render options here. And again, that's using the AVI settings. If we're using QuickTime, it's basically the same thing. You choose your QuickTime, you've got your codec options. One thing to keep in mind, if you're using a nonlinear editor that either wants AVIs or QuickTimes, it's best to use uncompressed rather than one of the codecs. The uncompressed files will be bigger, but you'll have a better time with compatibility between different nonlinear editors. I do want to touch on Film Expand just briefly here, because it is pretty unique, especially for people that are working in a combined film and video environment. What this is going to do is, as I mentioned, it does a 3-2 pull down. And to do a 3-2 pull down, it basically has to take 2 frames and interlace those together. So instead of doing 1, 2, 3, 4 frames in a row, you get 1, 2, and then third, fourth frame get interlaced to make up that third frame. And that's a way to compress 30 frames of animation down into 24 frames for film. Okay? So what we want to do here is we choose the Film Expand, then click on Options, and you can see that the options here are going to ask you what image format you want to save out and what your field dominance is. So if we choose our image format, you can see it gives you all the regular formats here. That's because even though it's an animation saver, it's going to save out a sequence of frames. And it has to be an animation saver so that it can get multiple frames in a row to compress those together. Okay, so you choose the frame you want, Target or JPEG or whatever it's going to be, and then you choose the field dominance. And we'll talk a little bit more about field rendering, but essentially, if you know what a 3-2 pull down is, or if you're going to be doing 24 film to 30 FPS, you understand this. But this is basically telling it which scan line gets the top line, whether it's the even or odd scan line. So that's going to set that up for you directly right in there. Okay, and then once you say OK, now when you render, it's going to save out a sequence of frames as your animation, and those will automatically be compressed as a 3-2 pull down. Now there are 2 other options here. There's the Save RGB and the Save Alpha. These just allow you to save a sequence of images, and again, you just turn it on, tell it what directory you want it to go to, and choose your format. Some of these formats are listed as 32, okay? Like there's a Photoshop and a Photoshop 32. There's a PNG 24 and a PNG 32. What this is the raw PNG file is the PNG 24. The color and alpha channel is the PNG 32. So this allows you to save frames that have the alpha channel embedded. All right? By default, LightWave just saves the color data. It's got the alpha channel information there, as we saw in the image viewer. But if you want that saved embedded in the file, you have to choose an image saver that has 32 bits. Some image formats, like JPEG, don't support alpha channels, so there's no option for that. Okay, but that gives you the option either way. Now, if you want to save your color data in JPEG, but you also want to have the alpha channel, that's why there's the option on screen here for Save Alpha. This way you can actually save the alpha channel as a separate file stream. Okay, so you would have a sequence of frames that had your raw RGB from here, then you have a sequence of frames that had your alpha channel that you can use for compositing. And this is kind of nice to have those saved as a separate file, because then you can do image processing to the alpha channels. If you want to blur those or you want to add some matting, you can do that as a separate stream. All right, so that's pretty much how you do your image saving. Again, that's handled all here on the output files. Your animations will save animation files. Your RGB are going to save a sequence of images, and alpha will save their own alpha channel as a separate file stream. And then on the bottom here, you'll see output file name format. And this just tells it how to name the files. So for example, the default is base name, which is the name you type in. Okay? LightWave will then add 00 and the appropriate frame number. And then a dot, the XXX, stands for the appropriate file type. So in this case, it would be name 001.als, because this is saving as an alias format. For the raw image, it would be .jpg, because that's the JPEG. All right? You can change this. If you don't want extensions, you can just tell it to be name 001. Or, depending on what other software you're using, some programs like to have 4 digits for the number. So you can save out 0001 and then the extension, or just the 4 digits with no extension. The next thing we want to talk about is multi-threading, and that's under the rendering panel here. You'll see multi-threading at the bottom is right now set to 1 thread. We've got 4 different settings. What are threads exactly? Well, multi-threading is how you take advantage of multiple CPUs in your computer. Okay, so if you have a dual processor machine, a dual G4 or one of the new dual Pentium machines, what will happen is LightWave will take advantage by starting threads, which means a process, on each of the processors. Okay, normally when you're using 1 thread and you go to render, just 1 processor is being used. Now the cool thing about that is you can be rendering on 1 processor, flip over to Modeler and keep modeling, and your model processing will happen on the second processor. Okay, so you won't notice any slowdown in performance in Modeler while you're rendering. However, if you're not going to be sitting at the workstation and you want to take full advantage of those dual processors, you can set multi-threading up to 2. All right, now you notice there are 4 settings, 1, 2, 4, and 8. Okay, well, since there aren't that many computers that have 8 processors in it, what is that 8 setting for? What is the 4 setting for? You can actually use those sometimes even on a dual processor machine. Okay, the way that LightWave does the threading is by dividing the frame into even segments. So if you're set to 2 threads, the top half of the frame gets rendered by processor 1, and the bottom half of the frame gets rendered by processor 2. Okay, that makes sense. So why would you want to set 4 threads on a 2-processor machine? Well, think about load balancing. Okay, let's take a look at a frame here, or a scene. I'm going to go ahead into our render options panel, close that up, and we're going to go ahead and load a scene here. And let's just go to the ray trace scene. Okay. Now this is a single processor machine that we're using here, so we won't see any speed benefits from the threading, but you'll get an idea of what's going on. So I'm going to go ahead and go to our camera properties again, and so that we can see what happens with multiple segments of rendering, I'm going to go ahead and set the segment memory here to 8. Again, I don't want this to be the default. And the reason I'm doing that is just to force it to render in 2 segments, which will sort of simulate the effect of multiprocessing. Again, since we only have one processor here in the computer, what I'm doing is forcing LightWave to render in 2 segments, just as it would if I had threaded this into 2, okay, across 2 processors. So what will happen is it'll render the first segment first, okay, up top, and then the second segment. Now, the reason I chose this scene here is because it's well load balanced. What that means is there are lots of polygons on both the top and the bottom half of the screen. Okay? So if we were using multi-threading, each processor would start, and the top half might take 2 minutes to render, and the bottom half might take 2 minutes to render. So as long as the top and the bottom take the same amount of time, both processors finish at the same time, and you're fine. Okay, I'm going to load a different scene here. We'll take a look at this one. Now in this scene, what you can see is the top half of the screen is mostly empty. Okay, up here, there's not too much going on. The bottom half of the screen is where all the action is. So if you have ray trace shadows on, this is where all the shadows are going to be, this is where all the reflections are going to be. All that ray tracing calculation is going to go on down here. So if we're using 2 threads on 2 processors, processor 1 is going to chew through this top half in just a few seconds. Meanwhile, processor 2 has to keep chewing on this one for a couple of minutes. So now you've got both processors start, okay? The first processor finishes segment 1 at the top in just a couple seconds, and now it's just sitting there idle. All right? So you're losing CPU time. So what you can do, even though you only have 2 processors, is you can set up your threads to 4 or even 8. Now there's a little bit of inter-process communication that is required to have those multiple threads, so you don't always just want to turn it to 8, because in some cases where the frame is well load balanced already, that'll actually slow it down because the threads have to talk back and forth. So what you do is you figure out what's going to be the best segment setting. For this one, 4 would work really nicely. What will happen is this top half here will get divided into 2 segments. You have a segment here, a segment here. So processor 1 will render the top quadrant, processor 2 will render the second quadrant. They'll pretty much finish about the same time. Then it'll divide up this bottom half into 2 chunks. Processor 1 will get the next segment, processor 2 will get the final segment, and thusly they'll finish at about the same time, which means they've been working for the same amount of time, which means less idle processor time and a faster overall render. So that's how multi-threading works, and that sort of explains the settings there. Again, if you're on a dual machine, 2 or 4 is generally the best setting, unless you have something that's really out of balance, where there's no polygons or no geometry at the top of the scene, then lots of stuff going on right at the bottom. Okay. Keep in mind that when you're rendering those segments with the multi-threading, it will have similar problems that you have with camera segment memory, whereas some processes like smoothing of shadows can be distorted a little bit. Threading's not quite as bad because it holds that stuff in memory before it passes it on to the buffers, but just keep that in mind if you see anything odd. Okay, the next thing I want to talk about is anti-aliasing. So we're going to go and load up another scene here. And this is, once again, our little robot guy, okay, from the robots directory. And what I'm going to do is I'm just going to render 1 frame. And this has no anti-aliasing turned on. Okay, so it looks pretty good. But what you can see, if we zoom in here, you can see it's a little bit chunky on the edges here, all right? So that's what anti-aliasing will help with. Anti-aliasing will actually go in and find areas that are not smooth and clear out those jaggies, okay? So where did we set that up? We're going to go to our camera panel, go to item properties, once again, and right here in the middle of the frame is a button called anti-aliasing, cleverly enough. So we'll go ahead and set low anti-aliasing, and now when I hit render, you'll see it renders the little guy here. And once it's done rendering, it's going to seek out edges. So you can see these white lines that go everywhere. That's actually the adaptive sampling that's going in there and seeking out where edges don't reach a particular threshold. Okay, so anywhere that there's a sharp border from one pixel to the next, it's going to seek that out and smooth it. And it adds a little bit of time to the rendering, but it creates a much, much better looking final render. Okay, so there's our final render there. We can open that up. Then you can see a much cleaner looking render. Again, using our page up and page down, we can switch back and forth. Luckily, NTSC may be smoothing that out for us a little bit, but that's definitely cleaned up the final render quite a bit. Now, it's important to understand the adaptive sampling threshold. Okay, that adaptive sampling is what allows it to go in, and those white lines that came out, and we're doing the smoothing. The adaptive sampling sets how different one pixel to the next has to be in terms of brightness before it actually goes in and does the smooth. All right, so the lower that number is, the more of the object that's going to get covered in that white effect that's actually going in there to smooth it out. So let's go ahead and take a look. If I go here to the adaptive sampling threshold and set this up to like 0.1, watch when I do the render here. You'll see once it's done rendering in the color, and it's going to seek out the edges. Watch how the adaptive sampling, see how much less of the object is covered in white here? Okay? That's because I've increased the threshold limit, so it's not going to affect as much of the image. It's going to be not quite as accurate of a anti-alias effect, but it was about 7 seconds faster. So we go in here, you can see between these two frames, they pretty much look the same. There's some small details if we zoomed in. Let's go ahead and do that. Okay, we're going to load some frames here. And we're just going to go out to our output directory. I've rendered some frames for us. Okay, very good. And what we're going to do is just look at several different frames. First of all, we're going to take a closer look of no anti-aliasing. So now you can see that's that same frame we were looking at a moment ago, but zoomed in, so you can see there's no anti-aliasing, and these edges look really atrocious. Okay? If we take that same mid-range look at low anti-aliasing, you can see immediately it looks much, much better. Okay? You can see where those edges have been smoothed out. Again, if we switch back and forth, using my page up and page down in my image viewer, you can see the drastic change from one to the next. Now, there's another setting on the camera panel called Enhanced Low. And basically, rather than just using the adaptive sampling, where it's seeking out those edges, it's going to re-render the frame multiple times with slight offsets. Okay? It takes a little bit longer to render, but you get a much, much nicer anti-aliasing effect. So let's take a look at one of those frames. So here we have Low Enhanced. Okay? And again, it's a little subtle, but if you look right here in this area, you'll see a nice change in the gradients, and there's a less banding, especially right in here as well. You get some banding effects that'll go away if you use that enhanced anti-aliasing. Okay? Let's go ahead and go to a close-up shot of that. Again, here's without any anti-aliasing at all, a close-up. Then low anti-aliasing. Low anti-aliasing with even a lower threshold, which smooths out some things in here. So again, if we switch back and forth, you can see how that really helps in there by changing the threshold value. And then finally, using the low enhanced anti-aliasing, it really gives you a nice soft effect. You can see if we go back and forth here, this is no anti-aliasing, then we go to low anti-aliasing, then we increase or decrease rather the threshold so it anti-aliases more, then we turn on enhanced low, and that gets even smoother. You can see the changes if I switch back and forth between those frames. So really gives you a good clear view there of the different types of anti-aliasing settings. Now if we take a look at the camera panel again, you can see on the anti-aliasing settings here, we've got the general setting, the adaptive sampling, which we already talked about. If we open this up, you can see there are many settings here. All right? And this just determines the number of passes that it does for the render. Again, if we have it set to low, it'll do the first frame of render, so it renders the color information, and then it does 4 passes of the anti-aliasing over the top of that. If we set it to low enhanced, it'll do 5 renders of the full image, blending those together. If we do a medium anti-aliasing, it'll render the first frame, and then it'll do 8 passes over the top of that to give you a total of 9 passes. Again, high will give you 17 passes. Just number of passes that it gives you increase incrementally as you go from low to high. Of course, it's going to take longer to render, but you can get some really fantastic results by setting those up a little higher. So it's sort of a trade-off between quality and speed. Most of the time you can get away with low enhanced, depending on the work you're doing. If you're getting some really intricate details, you might have to go up to medium enhanced, and sometimes with lots of motion blur or depth of field, you might even have to go up to the high or extremely high, especially if you're working in film or very high-res print media. Now to get motion blur on, you go to the camera panel. Again, camera is selected here, item properties opens right up, and what we'll want to do is go down under motion effects here, and you'll see there's a motion blur setting, and we've got it set to normal. You can also set it to dithered. We're going to start with normal first, and then I'll explain dithered in a little bit. Blur length is set to 100%. That's actually just basically 100% of a somewhat arbitrary value, but if you look down here where it says shutter angle and exposure time, this is actually the angle at which the camera will open, so how far the shutter opens. So at 100%, it's going to open all 360 degrees, and you can see it also shows you the shutter time, which is 0.0333 seconds. As we adjust this value here, if I set it down to 50%, you can see that's going to cut the exposure time and the shutter angle. So it's actually setting up sort of real-world camera values there to create that motion blur. Now to do the motion blur, you have to have anti-aliasing turned on. If we shut that off, you'll notice motion blur grays out. That's because motion blur requires a multi-pass rendering. Okay, so we'll go ahead and set this to just low anti-aliasing here. And we'll set motion blur to normal. And then I can hit F9, and you see it's going to go ahead and render the frame here. Now you notice it renders it once, and then it continues to render. This is similar to the enhanced anti-aliasing that we saw earlier, where it rendered the frame multiple times. But this time, instead of rather just jittering slight amounts of offset, it's actually rendering sub-frame frames, or sub-frame time frames. So you can see here multiple frames then get composited back together to give you that motion blurring effect. So what just happened there is we rendered frame 36, but LightWave rendered frame 36 and then 4 slices in between frame 35 and 36 and composite that together. So that's that sub-frame rendering time that actually allows you to get those time steps. Now what you'll see is we've actually got some sort of banding effects going on here. And that's kind of a problem, especially if you get real fast motion or high motion blur, so you'll want to get rid of that. Another thing we can do, because we used motion blur here, which did the frame rendered over and over again, we can actually now turn on enhanced low without sacrificing any time. That's because since enhanced low wants to re-render the frame every time, it's slower than regular low, but with motion blur it has to re-render the frame each time, so you might as well give it the enhanced setting. It's going to clean up the anti-aliasing a little bit, and it's not going to add any time since you're using motion blur anyway. Okay, so we've got the enhanced low, we've got the normal motion blur. If you want to set this to dithered motion blur, what that's going to do is it's going to render the frames in little sub-chunks. So you see where it says rendering pass here? It'll say 2A, then 2B, rendering 3A, then 3B. What it's doing is making just slight offsets on those A and B settings, and then it's going to dither those when it sort of composites them back together. So now instead of just having the 5 normal time steps, we have 5 normal time steps that have been subdivided in half and then slightly offset with a little jitter, which breaks up those bands a little bit. So you can see, if we look at our final rendered frame, that certainly cleared up the rendered frame quite a bit just by setting that on. Again, it does take a little bit longer. Now you can see that's up to about 20 seconds as opposed to the 14 seconds we had before. So that's the way the time-stepped motion blur works. And again, there are other ways to increase it, the quality. The higher the anti-aliasing setting, the more slices it's going to use on the subframe rendering, and the cleaner it's going to be. However, the more slices you use, the longer it takes to render. Now, if we just go ahead and turn that off altogether, and we'll do a render here of frame 36. So you can see the frame with no anti-aliasing and no motion blur. Okay, there's our normal frame. What I'm going to do now is activate vector blur. Okay, so vector blur we find under the Scene tab that you can see here, and then we're going to go down to Image Processing over here. That opens up our Image Processing tab, and you can see down under Image Filters here, I can choose Vector Blur. All right, and it's got similar settings to the camera, where you get the vector length, which is essentially like the blur length. We'll just go ahead and leave that on and hit Render. You'll see now it'll render the frame just like it did before. However, at the end of that, it's going to add the blur. And you can see now we get a very nice looking blur, very clean, no time steps like we had before with the regular motion blur, and it did that in 4 seconds. Okay? So that really gives you an idea of how much faster vector blur is than regular motion blur. And again, you can see without the motion blur, then with the vector. Let's clear this one so we can see vector blur versus regular blur. Okay, so there's dithered and there's vector. You can see even this between dithered and vector is still cleaner. If you look closely, you'll see some graininess in here from the dithering. Let's clear out the dithered and look at it just versus regular low anti-aliasing. There you can see the banding very badly, and again with the vector blur, a nice smooth blurring effect there. Now, one of the things about vector blur is we've applied it here and it went only in 4 seconds. That's because I didn't have any anti-aliasing on at all. Now in this case, the whole object was moving, so everybody got a little bit of vector blur applied. In the case where the foot goes to the ground and the robot pauses for a moment, there won't be any blur, and so you'll see the aliasing around the edges of the object. So what you'll want to do is just turn on low anti-aliasing with the vector blur. Okay, it'll increase your render time a little bit, not as much as regular motion blur would, but it's going to smooth that out quite nicely. Okay, it's important to understand how vector blur is able to blur these pixels. After all, this is just an image post-process. It's basically doing a smear, but it knows what direction each one of these pixels is moving. The way it does that is through one of the LightWave buffers called the motion buffer. So what I want to do is show you the actual motion buffers. We can actually see them. If I go down to image filter here, there's a tool called render buffer view. Okay, so I'm going to go ahead and drag that in the list here, make it first so it gets applied before vector blur. We'll open up the options, and you can see these are all the buffers that you get out of LightWave. Now earlier I was talking about the image view FP option and how it contained all those buffers. These are a lot of those buffers that are contained at each pixel. You've got custom surface settings, diffusion, mirrored reflections, raw RGB, shadow, Z buffer, which is depth. I want the Y motion and the X motion. Those are the two motion buffers. So the render buffer view will basically capture these buffers and display them as an image. So let's go ahead and make a render here again. And again, it'll render very quickly. It's going to apply the render buffer, and then it's going to apply the vector blur. Now we can take a look at these. So here's our vector blurred image. Above that, we can see an image that shows the blue, the outline of the robot, but just in shades of blue. Above that, whoops, one more, you'll see the robot in shades of blue and red. Well, if we look at the top of the panel here, you'll see that the top of the window is labeled X motion. All right, so everywhere that's red is moving in the negative X direction. Everywhere that's blue is moving in the positive X direction. If we go back to the other buffer, this is the Y motion, and you can see that everything's moving positive Y, moving up. Okay, so the blue indicates this leg is really moving upwards, whereas the body is just barely moving upwards. And of course, if we go back to X, you can see the motion there. So this is what vector blur uses. Vector blur uses these motion buffers and looks at each pixel and determines what direction that pixel is moving and how rapidly, and then blurs it appropriately. Okay, now the trouble with vector blur is that it's a linear blur, meaning that if you have things that are spinning, it's not going to blur appropriately. Like a helicopter blade with the time step blur would get multiple passes and get a nice rounded blur, whereas with vector blur, even though the helicopter blade is moving like this, the vector gets drawn in a straight line. Let's take a look at how that works actually. We'll go ahead and load up. Speaking of helicopter blades, okay, so here we have some blades, and you can see them spinning. This comes out of the aviation directory. This is the remote control helicopter that comes with LightWave 6. And what I'm going to do is go to the camera panel here, and we're going to turn on anti-aliasing, and we're going to turn on motion blur. Okay, and let's just make sure that vector blur is off. Good. And we'll make a render here, and you can see it. The helicopter blades are spinning very, very rapidly. So with the low anti-aliasing, you're going to get very few segments that are really sliced apart. But you can see how the edges of the blades actually get rounded because of that. Let's go ahead and go to high anti-aliasing here. Go to enhanced high. And this is what I was talking about, where you want to use a higher anti-aliasing setting. Now you can see instead of just those 5 steps, it's doing 17 steps. So now each pass of the subframe is a much smaller time step. So you get a much finer gradation on the blur. And ultimately, let's composite it back together. Now you get a really nice, again, rounded blur. This is exactly accurate to what you'd see if you photographed this effect as well. So what we're going to do now is go back to anti-aliasing and disable motion blur. We're going to go over to our scene tab, and we want to choose the image processing. Once again, choose vector blur. Okay, there it is. Just add that and make our render. And you can see very quickly how it renders, very, very fast. It's got a little bit more to do on the blur. But now you can see how the blur itself isn't quite accurate because it's only able to do these sort of straight lines. Okay, so if we take a look at these, you can see there's our vector blur. Here's our original low anti-aliasing motion blur. Again, adding more time steps smooths that out, gives you a nice looking blur, still a little choppy. Of course, that's high. We could go up to extreme anti-aliasing to really smooth that out. And then, of course, the vector blur on the rotated blades, you can see really not an appropriate time to use the vector blur. Now, there is a time when you want to use motion blur and vector blur together. In times of rotating or extreme motion blurs like this one, it's not such a great solution because it's only able to draw off that one vector. However, if the rotation of the blade were a slight turn as opposed to that giant arc, you can add motion blur and vector blur together. And what happens is motion blur gives you the basis of the smooth, accurate time-stepped motion blur, and then vector blur will just sort of add on top of that a little bit of smoothing. Let's take a look at a scene where it would be appropriate. We're going to go back to our robot here. And we've got our robot with motion blur. There he is, and good, we're on frame 36. Again, we'll go to our camera properties, make sure we're on enhanced low, and we've got, once again, we'll go ahead and render that quickly so we can see that in the time-stepped version. And do the 5 segments and recompute those, or composite those together. And we should see that stepping in there. Okay, you can see it here. Now, when you're combining motion blur with vector blur, there are 2 ways you can do it. And in here, to our vector blur option, we'll just open this panel here. You can see there's vector blur and there's blur mode. All right, so the mode here, vector blur, will actually use those vectors and blur along that line. Okay, or create a vector along that line. The blur mode will just take that pixel, and depending on how fast it's moving, it'll blur it. Okay, so in the case where you're combining these two, a lot of times it's better just to use blur. So let's take a look at that. We'll just add blur there, and you can see the blur strength. We can leave that on default. And again, it's going to come in here, and it'll render our 5 passes. And then what will happen is, in these areas where there's lots of motion, each of those pixels will get blurred a little bit. So in those areas of high motion, you get a smoothed out final result. Okay, so we're on our final step here. And then here comes the blurring. There you go. And you'll notice now, without much time at all, you get a really nice, accurate motion blur, but now without the addition of those frame steps. You can also use vector blur in there as well, but it's going to give you not quite the same result because it's going to be drawing lines. Depending on the scene, vector or blur mode combined with motion blur will be appropriate. So you have to sort of just figure out based on the content you're using. Generally, things that aren't moving too rapidly are really good for the time-based motion blur. Especially if you're using an enhanced anti-aliasing anyway, you can throw the motion blur on there and it doesn't cost you anything render time-wise. And then adding a little bit of vector blur with the blur mode will help blend that in. Things like flying logos that are flying around, and it's not necessary that the blur is highly accurate. You just need the blurring effect. Vector blur is perfect because you can knock those things out really, really fast. Cut down your render time by 2, 3, 5 times even. Other problems with vector blur or things that it won't handle, vector blur will not work behind transparent objects because, again, it is an image process, so there's no way for it to know what's going on behind those transparent polygons. And the other thing is the time-based built-in motion blur in LightWave will also motion blur shadows and reflections and refractions, all the things that get ray traced, because it's re-rendering the frame at those sub-time steps. And then any shadows, everything else gets calculated and recomposited back together. Of course, with vector blur, the motion buffer only contains object data. So only objects in the scene will get blurs applied to them from the vector blur. Okay, so motion blur is what we add that represents the effect of motion as an image is caught on film, and it really helps to smooth out from frame to frame in an animation. Now, in video, we do that a little differently. We do that with field separation, and that's because video is generally what we refer to as interlaced, which means that each frame consists of 2 fields, okay, or 2 subframes. In this case, on the bottom of the camera panel in LightWave, you just choose field rendering to either even first or odd first. And this is really dependent upon the hardware that you're going to export out to. If you're going out to a DDR or a tape deck, whatever it is, you should find out from the manufacturer whether they want even or odd field first. What that means is if it's at even first, the even fields, which is scan lines 2, 4, 6, 8, etc., will be placed forward in the frame, whereas odd first, the scan lines 1, 3, 5, 7, 9, etc. would be placed forward. We'll go ahead and set this to even first, and we're going to make sure our anti-aliasing motion blur is turned off. And we'll go ahead and render the frame, and you'll see now it's actually going to render frame 1, segment A and B. And what that did was, so you can see here how it's interlaced, frame segment 1, step A is the odd scan lines, and step B was the even scan lines, and then it separates them according to the motion. So you see here you get a little bit more ghosted motion in the interlace. Here, up here, where the object's moving less, you get a little bit less of a separation. Now, the nice thing about this is when you play back an animation that's been rendered with field rendering on a television monitor on tape deck, it actually looks really smooth. So some people who create animation prefer to turn this off because they like that film look, which is progressive. Okay, progressive means that there are no interlaced fields. Each frame is a solid time step, whereas in video, each frame is actually 2 time steps represented in fields. So if you want something that looks like video, you want to turn on field rendering. If you want it to look like film, you want to, of course, turn off field rendering and just use motion blur. You can use both together, so you get a motion blurred effect with the field render. Let's go ahead and take a look at these animations played back here. What you see now is the animation with no motion blur. So you can see it looks a little choppy. The motion kind of has a stepped feel to it because there's no representation of blur or field separation. Now what we're seeing is the motion blurred example, and it's a little flickery, kind of like film would be, but the motion blur effect on each frame helps to smooth out the motion in between. It gives the illusion that you're actually seeing the motion as opposed to several frames just flipping by. And finally, what we're seeing here is the item field rendered, and you notice how this sort of has a video look to it. It actually kind of makes it look cheesy in some ways, but that's just because we're used to seeing video, and we see it, we think of a lower quality as opposed to that film, which actually in fact is less data, but just looks a little higher quality because that's what we're used to. So you can see LightWave gives you a lot of options for the way you represent motion. You can either just turn everything off, you can use motion blur, you can use depth of field, you can use them combined. It really depends on your intended target viewing device. If you're going out to play it just back on your computer as an AVI or QuickTime movie, you'd want to go progressive, which means non-interlaced. So you would not use field rendering. If you're going out to a television monitor, of course, you'd probably want to use field rendering, particularly if you want to give it that video look. And then, of course, if you're going out to film or HD TV, where they use progressive frames, obviously you would just use motion blur and no field rendering. Now, the next thing we're going to take a look at is another camera effect called depth of field. All right, so let's take a look at how we set that up. We go to our camera properties here. You can see, again, we've got enhanced anti-aliasing turned on. Then we've got a little motion blur to add the motion. Then under stereo and DOF, which is depth of field, we have some settings in here. Under there we have depth of field turned on. There are 2 settings. One is the focal distance and one is the lens f-stop. Okay? Now, depth of field, if you've done any traditional camera work, is actually a fairly difficult thing to work with because there's a lot of different variables you have to add in. It depends on several different input parameters. For example, you have to know what lens size you're using. You have to know about your focal distance. You also have to know about your lens f-stop. So there are all these different things you have to figure out to get an item in focus and then to determine what the near and far plane of focus is, so you have that range of items that are in focus. And all those things sort of interrelate to each other. So it's actually a cool utility you can get online. There are several depth of field calculators. If you go into any search engine and just type in depth of field, you'll find links to many, many depth of field calculators. But there's one specific to LightWave created by Ernie Wright. And you can get that off of flay.com, which is www.flay.com. If you go to the tutorials section and do a search for DOF space toy, you can download it for free. Let's take a look at how it works. We're going to go ahead and load up a different scene here for the depth of field. Okay, and we have our little Scout Walker scene here. And again, this is a scene that comes out of the content. I just changed it around a little bit, the camera position. And what I'm going to do is I'm going to go into the depth of field toy, and I've actually got that assigned to a hotkey. If I didn't, I would go into display here. After you've added the plugin, You go to plugin options, then I'll go to my generics here, I'll go to depth of field toy, and you can see that it's got all the different parameters that I want to consider inside of my depth of field effect. For example, it's got the near and far plane, which tells you how near the camera things will be in focus, how far away they'll be still in that focal range, and the exact focal distance. It's got the camera's f-stop, the camera zoom setting, and there are a couple check boxes. These check boxes allow you to lock down particular values. So if we go down here, you click on this button that says copy from scene, that actually gets the data from the LightWave camera. So right now inside of LightWave I've got a focal distance of 2.5. I've got a zoom setting of 3.2. The f-stop here is set at 1.2, which with all these settings, of course, you've got a near plane of 1.2 meters. The item at 2.5 meters will be in focus. So and this also allows you to pick what kind of camera you're using. That's also very important because that gives you the camera size. Okay. So the way we can use this, if we come back out here, I've actually got a null object here that I've added to the scene that's parented to the item. So as it moves, you see it tells me the distance. The way I've done that, if I go to my objects properties here, under custom object, there's a tool called rangefinder. If you choose that, it'll turn this little null object into a rangefinder that'll tell you the distance between it and any item in the scene. If we double click on a little panel here, you can see that I've got the item set to camera. I can also tell it to draw a link, which will draw a link from the camera to the item. I don't necessarily want the link. I just want to see how far away that item is from the camera, and so it's always going to have that little heads up. So now if I drag it through, you can see that value is changing. I did that so that I could choose at what distance I wanted the object to be in focus. Okay? So we go back to the camera's item properties here. You can see I had my focal distance set to 2.5. So that means when the item gets right about the very beginning here, I'll just move this out of the way, you can see that 2.5 is right about there. So that's where it's going to be in focus. So now if I want to know where the near and far planes are, again, go into the depth of field toy here, you can see I know that this will be in focus all the way up until 1.2 meters. So as it gets pretty close to the camera, it'll still be in focus. If I want to see how to narrow that near and far plane, all I have to do is start adjusting these values. We'll leave the f-stop alone. We'll leave the zoom alone, and we'll adjust the f-stop. And you can see that as I increase the f-stop, my near plane gets lower, which means it can be closer to the camera and still be in focus. If I start to decrease my f-stop settings down below 1, you'll see my near plane starts to get larger, which means it'll actually be out of focus sooner. So you can actually tweak these guys around and see how they interrelate to each other. It really helps with setting up your depth of field effect. All right, let's go ahead and take a look at this animation as this plays, and you can see actually as the robot comes walking through, you can actually see the areas where it's in focus, and then as it comes toward the camera and eventually goes out of focus. Also notice as it's walking by the towers, the ones very close to the camera are out of focus, the ones very far away from the camera are also very much out of focus. The one in the middle there, you can see it's actually in a little bit better focus because it's sort of in that in-between range. So it gives you an idea how the LightWave depth of field works. And again, it requires the multi-pass rendering, so it's going to add a little bit to your render time, but it does give you a very accurate result to what depth of field should look like. All right, now LightWave's depth of field uses the multi-pass rendering just like its motion blur does. Well, just like vector blur had the blur mode, there's a depth of field blur that will do the same thing, but based on the depth of field effect. So what we can do is we can actually use a lower setting of time steps and then add the depth of field blur to smooth that out. So let's take a look at a frame here. This is frame 180 rendered with medium anti-aliasing and depth of field, and you'll see as the robot gets very close here, you start to see the time steps, the separation in the depth of field render. Okay? So what I've done is I've actually added depth of field blur, and you can see now you get a really smoothed out blur here. So without adding a bunch of render time, it really assists in that depth of field blur. So you can see there with the depth of field blur, here it is without, you notice it really adds a nice soft touch to the final render. You can notice on the shoulder of the robot there, it really blends that in. Whereas here you get that nice, that nasty banding. Here you get the nice smooth, blurred out effect. So that really helps just to add a little bit of softness to the depth of field without adding a whole bunch of render times by making separate steps. Okay, the next rendering effect we want to talk about on the camera panel is stereoscopic rendering. And you'll see that shows up right here under stereo and depth of field. And basically, this is just the ability to render out imagery that are going to be used for a stereoscopic system. There are many different types of stereoscopic visualization tools. There's, of course, the red-green separation. There's the eye shutters. There's two screens being displayed simultaneously. Well, LightWave pretty much handles any of those. The built-in mode, stereoscopic rendering, gives you one option, you can see here, and that's for eye separation. And this basically just sets the distance between the two eyes. What's going to happen when you render that is it's actually going to render out 2 frames for every frame. It'll render out a left eye and then a right eye. So when you do a test render, it'll always just render the left eye. When you go to render your final animation, it'll render out a frame called frame name L and the number and the extension, and then frame name R and the number and the extension. And that represents the left eye's perspective and the right eye's perspective. Okay? Then it's up to you if you wanted to composite those together interlaced for an interlaced stereoscopic system, or if you want to keep them separate for systems that use 2 monitors flashing at the same time. LightWave also has the ability to do the red-green separation that we're used to, or excuse me, the red-blue separation used to from the old school 3D movies. And to do that, we actually go to image processing, and we go down to image filters here, and you choose the Anaglyph Stereo Simulate. So Simulate will allow you to do this without rendering 2 passes. It'll actually just use the Z buffer that we were talking about earlier, which tells each pixel how far away from the camera it is, and it'll separate the red and blue. Let's go ahead and take a look at an example here. We're going to load up a scene. And I've just got the toys scene off of the LightWave CD here. Okay, there it is. And we've got Anaglyph Simulate turned on. Again, it's got an eye separation. I've increased this. Normally it would be about 1.1. Okay, I've increased that to 4. That's in inches. Just so we get a little bit more drastic result here. We'll hit F9, do a render. You see it renders the frame. And then it comes in and does the Anaglyph simulation. And you can see how it's separated the red and green across here, channels from the image. You'll notice as the pixels are further away from the camera, you get more separation. Pixels that are closer to the camera, you get less separation. So as it goes back, you get more of a 3D effect. This is sort of the in-focus range, if you will. And finally, the other option in image processing here is for Anaglyph Stereo Compose. If you're using LightWave's internal stereoscopic rendering, where it actually saves out 2 files, this will compose those 2 together using each file to create the proper color separation as it creates that red-green separated image. Okay, there is one more type of stereoscopic rendering in LightWave. We talked about this just briefly earlier. Under Save Animation, under Anim Type, there's a QuickTime Stereo option, and this will actually create a QuickTime movie with the colored separation set up for stereoscopic viewing. The next thing we want to talk about in terms of the LightWave render, and possibly the most important thing, are the LightWave lights. There are 5 different light types. There's a distant light, point light, spotlight, linear light, and area light. And each one of these lights have different attributes, a different effect on the scene. So it's very important that you understand how each light reacts with the objects around it, so that when you're setting up your scene, you can choose the appropriate lighting type. Let's go ahead and take a look here. We're going to go ahead and just load up a basic scene. Again, we're going to go back to our good friend the robot. Little walker, and we'll start with a distant light. Now, a distant light is essentially a light just like the sun. So we can see here is our distant light. And a distant light, because it is like the sun, it's basically creating a wall of light that gets emitted in the direction that the light is facing. All right, so that means I can move my light anywhere in the scene. You'll notice it doesn't make any change to the robot at all, no matter where I put it. However, if I rotate that, you'll see there is a dramatic change in the lighting of the scene. Okay, just like a giant wall of rays are being projected down. And again, if we make a render here, we can see our little robot guy as if he's lit, and it sort of has that sort of daytime light because it's getting a whole wall of rays shine down upon him. If we go back over here, we can change our light type. We go to our Lights tab here, and with the light selected, there's a light type pop up here, and we can go from distant to point light. The point light is going to work basically like a light bulb, where it's going to emit rays in every direction. So in this case, if we go to rotate the light, you'll see rotation doesn't change the lighting's effect at all. However, if we go to move the light, as you can see here, it actually does make change to the scene. If we go in and then we make a render here, you can see that it has a different look. You see a nice fall off here. This is more like the lighting you'd find in a room. It's more like a light from a light bulb. So again, let's just open up our final render here. You can see there we are from a point light, and here we are from a distant light. Again, this is more like an outdoor light. This is more of your indoor lighting effect. The next light type, we have our light selected, is spotlight. And guess what? A spotlight works just like a spotlight. So if I rotate that around, you can see actually the effect of the light as I move it. One of the interesting things you can do is you can change your view. If I look at the pop-up here in the top corner, you can change your view to a light view. Now I can actually see the perspective of the light. Looks like we've got it rotated around. There we go. So I can see exactly where the light's pointing if I want to position it exactly the way I want. Then we'll just go back into our perspective view, and we'll render that. And so now you can see spotlight. You get a nice area where the spot is shining down on it, so it looks exactly as you'd expect a spotlight to look. Okay, so now we've got 3 of those examples. Let's go ahead and change our light type again. This time we're going to go to a linear light. And a linear light, as you can see here, is sort of like a neon light. So what I'm going to do is go ahead and rotate that around here a little bit. You can just grab these handles, and we'll just get them kind of lined up like that and make a render. And a linear light is essentially a row of point lights. Okay? One of the cool things about a linear light is that it gives you these nice soft shadows. You can see it does something interesting in the shadow because there's a whole row of light coming down. It does take a little longer to render, but it gives you a really nice soft edge shadowing effect. Okay, and you can see that again here. So that's more like light from a tube. And finally, light type of area light. And we want to go ahead and look through the light's perspective so we can see which way it's facing. Okay, and we'll just move it a little bit like that. It's actually very handy to be able to look through the light's perspective. And back to our perspective view. We make a render. And now you can see this. Area lights give you a really nice effect. Again, they take a little bit longer to render, even a little longer than a linear light, but it gives you a really nice effect. And one of the great side effects of having the soft edge shadows is the closer the object is to the shadow, the more in focus that shadow will be, and the further away, the more it will fall off, just like a light in the real world would. Now, the area light and the linear light are essentially an array of point lights. And there is a light quality setting for the area and linear light. You find that on the light panel. It's by default set at 4, which for a linear light means there are basically 4 point lights along that area. For an area light, it's an array of 4. So that means 16 lights, 4 by 4, in an array inside that visual box that we see. And that's how we get those really nice ambient light effects from those light boxes. You can, of course, see here from the final render that it gives you a really nice effect on the shadowing here, as opposed to something like the area light, the distant light, which we see here. This gives you a nice harsh shadow, but a lot of times what you want is something that's the nice soft edge shadow here. It's a little bit more realistic. So you can do some really nice things there. Let's go ahead and talk about some of the light properties. We're going to go ahead and go to the item properties. If we go to light here, and we open up the properties panel, we can also change the light type from inside this panel. So let's go ahead and look at the different light types and their properties, what they've got available. A distant light is the simplest light because it doesn't have any real settings to deal with. It just sort of projects this light and you're kind of done. A point light, same basic situation. The spotlight, however, has some nice settings you can change. For example, you've got the spotlight cone angle, so you can adjust that. You've also got the spotlight soft edge angle. So if we set that to 0, for example, and let's just go to our light perspective again. And while we're in the light perspective, we can adjust the cone angle to narrow that down, we'll go ahead and make a frame render, and you can see now the spotlight is very tight. Okay, not only is the spotlight tight, but the soft edge cone angle has gone away, so it's a harsh edge around there. Okay, if I turn my soft cone edge angle back up, let's go to maybe 10 here, 10%. That means the whole thing is going to be 14%, or 14 degrees rather, open, and then the majority of that is going to be soft edge. We can see here fades that in. Okay, so you can increase your cone angle and increase the soft edge with it, and that'll give you a really nice soft spotlight. So you can see the extremes there, this really nice soft spotlight here, or the harsh edge one there. And you can just change that by setting the cone angle and the spotlight soft edge angle. With spotlights, you can also project images. So if you take an image map, you can put in there and project that. So if you want to project like a film strip or a movie file or a frisket to simulate tree branches, that sort of thing, you can create something that looks like a window pane, shine right through there. Let's take a look. This is generic panels, which is the texture right off the model. Should be a somewhat interesting texture. And there you can see how it's projected that image map down onto the object. Okay, we'll go ahead and turn that off. The next setting we've got is the shadow type. In this case, it's set to ray trace by default. You can turn it off so it doesn't cast any shadows at all, or you can set it to shadow map. Now, shadow map is only available to spotlights, and shadow maps will render faster than ray tracing, but they're not quite as accurate. Let's go ahead and make a render here. One of the nice side effects of a shadow map light is that the edges are a little softer. Looks pretty nice. There are a couple settings here for the shadow map. One is the shadow map size. So basically what's happening is, from any light that you're using a shadow map from, it's casting out a grid. In this case, it's a grid of 512 by 512. And in that grid, a point can either be on or off. So it looks through there, and you get sort of a binary approach to the shadow. With a 512 by 512, you shouldn't notice any edges. If you get really close to the light, or if you spread the light way out, those grids are going to get larger, and you'll start to see kind of a blocky area. And then you can set on the shadow fuzziness here. You can increase that. If we just turn down our shadow map size, let's turn it down to like 64 and make a render. And you can see now the shadow got a lot chunkier. Okay? See that? How it's less accurate? Let's turn down our shadow map fuzziness completely off. And you can actually see now the blockiness of the shadow map. Okay? See how terrible that looks? Well, that's how shadow map is doing. It's doing a little trick where each one of these little blocks in an array of 64 by 64 blocks can either be on or off. But that allows it to render very, very quickly. In the case of 512, you can see that without the shadow map fuzziness, it's still got the aliasing effect, but it looks pretty good. You turn on a little shadow map fuzziness, and all of a sudden, voila, you've got a fast shadow. It looks pretty darn tasty. Okay, looks pretty nice there. Of course, you can crank this way up. The expense for shadow map size is just memory, just takes more memory. So it's a trade-off between memory and quality of the shadow. Now there's another setting here called Cache Shadow Map. And what this allows you to do, if you activate it, it will take the shadow map of the first frame and just leave it for the entire animation. Now you may wonder, why not just turn this on for all shadow map lights all the time? Because then you only have to calculate the shadow once. The problem is, if something moves underneath that light, its shadow will in fact not move. So let's take a look at an example of that. I'm going to go ahead and set my cache shadow map turned on, and down here I'm going to set my first and last frames. Go to rendering options here. Set my first frame to 1, my last frame to 54, but I'm going to tell it to render a frame step of 5. So it's going to render every 5th frame. Go ahead and turn off the image viewer, and I'm going to push F10, which starts to render. I'm going to tell it to go ahead and, it's just warning me that I'm automatically advancing the frames, but I don't have any saving options. That's fine. I'm not trying to save the frames. I'm just trying to illustrate a point here. So I've got shadow map cache on, so the first frame looks great, right? Now watch what happens as the foot moves away from the object, the shadow stays put. My character is still moving, but my shadow is locked in place because it has cached the shadow map from frame 0 or frame 1. Okay, so immediately this shows you a downside to using a cached shadow map. So when would you use a cached shadow map? Well, let's say, for example, you're creating an animation of a room, And in that room you have some furniture, and in the back corner is a lamp with a shadow that's casting down onto the floor. Well, if nothing ever moves inside that light, you might as well just cast that shadow, because it's never going to change in the scene anyway. So if you're selective, you've got certain items in your scene that are stationary, and you've got a light that's casting a shadow onto that object, cast their shadow map at that frame when nothing else is there, so it's not going to move through it, and you'll save yourself a lot of time. Okay, let's go back to the light properties, and we'll change our light type here to linear light. And here again you can see your linear area light quality. All right, and that's where we set up basically the number of lights that make up the actual linear light. Again, for area light, you have the same settings. Now, if we turn this down a little bit, let's turn down to 3 and do the render again. That's going to render a little more quickly. What you'll see is it gets a little bit fuzzy. Okay? There's a setting now inside of LightWave 6.5 that will actually help with that. You can see the anti-aliasing here, because the adaptive sampling threshold is pretty high, or pretty low rather, is really hitting all that area. I'm going to go ahead and stop this from rendering. Let's go to our camera options here. It's going to turn off anti-aliasing, and we'll make a render here so we can see it quickly. I really want to show you the graininess that we get from having that low quality setting on the area light. So there you can see the area light looks nice on the object, but down here the shadow really grainy. Okay, so I can fix that again by turning up the quality setting here, okay, or by using multipass rendering. Now, if I use multipass rendering, for example, enhanced anti-aliasing, every time it renders a new step, it's going to jitter those lights again. So it'll give it a randomly created shadow on each frame. So each frame will be slightly grainy, but when you blend those all together at the last pass, it really smooths it out. Now, another function you can use inside of LightWave 6.5 is called shading noise reduction. If we go to our light panel here, at the top of the light panel is an option called global illumination, and inside there is a button called shading noise reduction. Okay, we'll turn that on, go back to the light panel, we'll leave that at 3, and again, rather than having to multi-frame render this, we'll leave it at 1 pass. It's going to render out the grainy version, and then here comes the shading noise reduction, and boom, you see how that really smoothed out the shadow. That combined with the multi-frame anti-aliasing will really create a nice looking smooth area light shadow without having to crank up the area light quality too high. Now there's another way to create a nice looking light without actually using area lights and give you a soft edge shadow. This is a trick I learned from my friend Manny Tsaservis, and what it does is it uses a spinning light trick. So I'm going to show you how to set up a spinning light to create a nice soft edge shadow without having to use area lights. So in this case, we're going to do it with a shadow mapped spotlight. So I'm going to go ahead and load up a scene here. Just as our scout walker. Okay, there it is. And we'll go ahead and choose our light. And we see our light there. Again, this is right now a distant light. So go to the light properties panel, change that to a spotlight. And what I want this to do is I want to change the light's angle at every subframe render step. Okay, so what we have to do is first of all turn on motion blur. So go to our camera options, under item properties, we'll turn on enhanced anti-aliasing, and we'll activate motion blur. Okay, so for this scene we know we need motion blur anyway. And for most scenes you're probably going to use motion blur because it really does enhance the effect of the render. So since we're using motion blur, we know that in between frame 1 and frame 2, it's going to render several steps. So in that intra-frame step, what we're going to do is we're going to make the light rotate around 1 full revolution inside of that 1 frame. So from frame to frame, the lighting will always be exactly the same. But in between those 2 frames, it'll have some variance. And what will happen is LightWave will take all those variants and compose them together to give us a nice smooth effect. Let's take a look. We're going to go to our light here. I need to add a light spinner. So I need 2 null objects. So I go to my items here. We'll go add objects, null object. We'll call this one spinner. Do the same thing again. Add null. Call this one target. Okay. Now what I'm going to do is I'm going to go to my motion options for my target item, and we'll hit the M key here that opens up motions, or I can click on the motion options button. And for parent, I'll tell it to be parented to the spinner. Now I'm going to move it out a little bit like this, away from the spinner object. And then I'm going to take the spinner here, and I'm going to go to frame 1, and I'm going to rotate it. I go to Rotate Options, Heading, 360 degrees. Create a keyframe. Okay? So you can see that from frame 0 to frame 1, it rotates 360 degrees. You can see that by looking at the numeric, but the actual null object doesn't move at all because all the rotation happens in the subframe. Now we need that to repeat, so we'll go to Graph Editor up here. We click on the Graph Editor button, choose Rotation Heading. You can see it here, and we'll tell its post behavior to be repeat. And you can see it's just going to repeat that rotation forever and ever and ever. So as I scrub through, you can see the nulls look like they're not moving at all, but in fact, in between each frame step, they're spinning and spinning and spinning and spinning. So now the light, we go to its motion options, and we tell it to target the item called target. Okay? So again, now as we scrub through, the light appears to be stationary, but what we don't see is in between each frame, it's actually targeting that light that's spinning around. So it's chasing it like that. So it's going to give us a nice different variation to the shadow on each frame. So if we go to any frame here, hit Render, you see at each frame, each subframe, you get a little variation on the shadow, and then it'll blend those together, and it gives us a nice soft edge as it gets further away, and a tight edge as it's in here. This is useful for spotlights and distant lights. If you're using it the same trick on a point light, remember that point lights the rotation of a point light doesn't affect the scene. So what you'll do instead is make a spinner that's right next to the spotlight, and then the point light, and the point light would then spin around that 360 degrees at each frame step. So just kind of a cool little trick if you want to improve the lighting. You can also do this with area lights. It does increase the render time, but you get some really fantastic looking renders doing that. Okay, aside from the standard 5 light types, there is another light source. That's called ambient light. So let's open up the item properties for the light here. I'm going to go ahead and turn off this light altogether. So you can see now we're in a dark environment here. Now you notice there's still a little bit of illumination on that object. Well, that's the ambient light. And we get to that under global illumination right here. And you can see ambient intensity. If I crank that up, you can see how it's lighting everything up. But notice how really flat everything looks. Okay? That's because everything in the scene gets the same amount of illumination from ambient light. So you really want to keep this to a minimum. It's at 25% by default, and frankly, that's just too high. The reason it's at 25% by default is that so the one standard light that's in LightWave and the ambient light together, when you load any object and hit render, it'll look pretty decent. But as soon as you start to build a scene, you really should drop this down to 15 or 10 or even 5% before you do your renders. Now, of course, we'll have to bring our light back up from our spotlight. But that's going to give you a much more dramatic effect. Really what ambient light is trying to assimilate is bounced light, or what we call global illumination, light that bounces off the walls, everything else. There's light that comes from all directions, not just the light from the lights in a room, for example. But in 3D, without global illumination or radiosity rendering, you're not going to get that effect of bounced light. So ambient light is just a very quick and dirty cheat to give the entire environment a little bit of light. A lot of times what you'll want to do actually is even tint the ambient light color. If it's a nighttime or an evening shot and you want sort of a sunset approach, you might tilt it a little bit towards orange. If it's an outdoor day shot, you might tilt it a little bit towards blue. So everything just gets a slight tint. But again, the best thing to do by default is decrease that ambient intensity down to 5% or even lower, and then use actual lights in LightWave to do the lighting. You get a much more dramatic effect and it'll look a lot more photorealistic. Of course, as I mentioned, the radiosity effect in global illumination, a great way in LightWave 3D to create incredibly photorealistic effects, but that's going to be reserved for Render 2. That's going to wrap it up for us today with Render 1. We hope you've enjoyed yourself and keep on rendering.